$1,400. That's what the average homeowner gets quoted for a full attic insulation overhaul this year. Some markets, it's worse. I've seen quotes north of $3,000 for a standard 2,000 square foot attic, and half of that number has nothing to do with actually stopping heat loss. It's markup dressed up as material. I'm going to show you the exact upgrade that costs less than $60 and does more real work than half of what's sitting in that quote. Not a theory, not as some experts say, an actual fix with actual parts that you can do this weekend. I've crawled through enough attics, old farmhouses, new builds, everything in between, to know the difference between a real fix and a sales pitch dressed up in energy, audit language. And what I'm about to walk you through, contractors don't lead with it on the estimate, not because it doesn't work, because it works too well and there's no markup in a $15 piece of foam board. They don't want you to know this. So sit down, get a coffee, because we're going into the attic and we're going to talk like people who have actually been up there with a headlamp and a knee pad, not like a showroom brochure written by someone in a call center who's never touched a rafter. I've watched this exact scenario play out more times than I can count. Homeowner calls 3 companies. All 3 send a rep. All 3 reps climb up, shine a flashlight around for 90 seconds, climb back down, and hand over an estimate that's somehow always priced to hit a package tier instead of the actual square footage and actual condition of what's up there. It's not a coincidence. It's a pricing model built around anchoring you to the biggest number first, so that even the discounted middle package still feels like a deal, when in reality the real fix costs less than the tip you'd leave on that estimate. So before we go any further, I want to set the tone here. This isn't a video about hating contractors. Plenty of them are honest, skilled people doing real work. This is a video about the system a lot of them are forced to operate inside: commission structures, franchise quotas, rebate program incentives that push even well-meaning people toward the expensive fix instead of the correct one. Once you understand the system, you stop being a target for it. Here's who's making money off your ignorance, and I'm going to name it plainly because nobody else will on camera. First, the big regional insulation contractors who show up, glance at your attic hatch, and quote, "whole attic replacement," before they've even gotten a tape measure on what's already up there. They know most homeowners can't tell R13 from R49 just by looking at it, so the estimate gets built around fear. Your attic is basically empty, instead of an actual measurement. Second, the utility rebate programs. These get marketed as consumer protection, and sometimes they genuinely help. But look closer at how a lot of them are structured, and you'll notice something. The rebate tiers are often written in a way that nudges homeowners toward the most expensive upgrade package, the one where the contractor's margin is baked into the approved vendor pricing. The rebate looks like savings on paper. In practice, it's steering. Here's what happened, and I can actually point to roughly when the shift occurred. Back when blown-in fiberglass and cellulose became the default retrofit recommendation industry-wide, the whole trade realized something simple. Homeowners don't understand what R value they actually need. They just understand more is better. The same way people think more horsepower always means a faster car, regardless of what's actually limiting performance. So the sales pitch shifted. It stopped being, let's find where your house is actually leaking heat, and became, let's add more material. Because material is what gets billed by the bag, by the pound, by the truckload. And here's the technical detail that proves the whole thing is backwards. Heat loss through an attic is overwhelmingly driven by air leakage, not by a shortage of raw insulation thickness. I want you to sit with that for a second, because it's the single most important sentence in this video. Warm, moist household air escaping through gaps around recessed can lights, around plumbing stacks, around electrical penetrations, around the attic hatch, and along the top plates where your interior walls meet the ceiling. That air movement carries far more heat out of your house than simple heat conduction through a blanket of fiberglass or cellulose ever will. You can pile R60 of loose fill insulation on top of an attic that still has unsealed air pathways, and you will still lose heat like a sieve in January because the warm air is bypassing the insulation layer entirely. It's finding the gaps. It doesn't care how thick the blanket is above it if there's a 2-inch gap at the top plate letting it right through. Contractors know this. It is not a secret. It is basic, published building science that's been in Department of Energy technical literature for over a decade. But sealing air leaks, first, is fast, it's cheap, and this is the part that matters to their bottom line. It doesn't fill a truck with material. So on most estimates, it gets glossed over, mentioned in a single vague line item, or skipped completely in favor of, let's add 12 more inches of blown in. Let me give you a real-world comparison, because numbers stick better than abstractions. Picture 2 identical attics. Same square footage, same climate zone. Attic A gets the standard treatment. Crew shows up, blows in another 10 inches of loose fill fiberglass on top of the existing insulation, charges for labor and material, done in half a day, invoice for around $1,800. Attic B gets air sealed first, hatch, top plates, can lights, penetrations, and only then gets a modest topping of new insulation to bring it up to code minimum. Total cost for Attic B, including a modest amount of new blown-in material on top of the ceiling work, often under $400 if you're doing the ceiling yourself and only paying for the material top-up. Building Science, modeling on this exact comparison, and this shows up again and again in Department of Energy retrofit case studies, consistently finds that Attic B performs as well or better on actual measured heat loss than Attic A, despite costing a fraction of the price. Same climate, same house. Wildly different result for the homeowner's wallet and almost the same real-world performance. That gap between the two numbers is where a whole industry has quietly built its margin. And it survives specifically because most homeowners never see this comparison laid out side by side. Now you have. There's also a seasonal angle nobody talks about on the sales call. Attics that are heavy on material but light on ceiling tend to develop what old-timers call insulation settling channels, spots where moist air repeatedly funnels through the same weak points over years, slowly compacting or degrading the loose fill material sitting directly above the leak. So not only are you not getting the R-value performance you paid for on day one, that performance can actually degrade faster over time, specifically at your leak points, while the rest of the attic insulation stays fine. It's a slow, invisible failure that never shows up on an invoice, and it's exactly why some homeowners redo a fully insulated attic, again 10 years later, and are told, again, that they need more material when what they actually needed the first time was sealing. Here's what the guys who've actually been doing this since before energy audit was a marketing buzzword already know, the old-timers who learned building science before it became a sales script. Air sealing before insulating isn't a nice-to-have. It's not step 4 on a checklist. It is the entire game. The Department of Energy's own Building America program has published this for years, and it isn't controversial in the building science world. Air sealing paired with even a modest insulation upgrade consistently outperforms a heavy insulation-only job, because convective heat loss through gaps and cracks absolutely dwarfs the conductive loss you get through the insulation material itself. Let's talk about the actual parts, by name, because I want you to know exactly what to look for the next time you're up there with a flashlight. Top plate gaps. Where the drywall meets the top of the framing on every single interior wall in your house, there is almost always a gap, sometimes a hairline crack, sometimes wide enough to fit 2 fingers through, especially in older framing, where the lumber has shrunk and shifted over the decades. These gaps are basically open chimneys running straight from your heated living space into the attic. Warm air rises. It finds these gaps. It leaves. All night, every night, all winter long. Recessed can lights. If they're not IC rated, meaning insulation contact rated and airtight, they are constant, ongoing leak points. And worse, they're often surrounded by a gap in the drywall cutout that's even bigger than the fixture itself. Old-style can lights generate heat and were never designed to be sealed, which is exactly why so many homeowners have been told never put insulation near a can light. True for the old style, not true for the airtight retrofit versions, which we'll get to. The attic hatch, or pull-down stair. This is, in my experience walking through hundreds of attics, one of the single largest uninsulated, unsealed openings in the average American or Canadian home. It's a hole in your ceiling. Most of them have zero insulation on the hatch panel itself, and zero weather stripping around the frame. Contractors barely mention it because there's no product to sell around it that carries real margin until they invent a $300 insulated attic tent for something you can build yourself out of foam board for the cost of a fast food order for 4. Now here's the documented evidence, because I'm not asking you to take my word for it. The Department of Energy has run field studies specifically on what they call ICAT retrofits, insulation contact, airtight, on recessed can lighting alongside hatch sealing studies. The consistent finding? Sealing these specific penetration points produces a measurable, repeatable reduction in attic air leakage, and dollar for dollar, it frequently outperforms simply adding another 6 or 8 inches of blown-in material on top of what's already sitting up there. This is published it's not a rumor passed around a job site. It's sitting in technical literature that gets buried under 100 pages of upsell paperwork designed to steer you toward the expensive option before you ever get to the boring, cheap, effective one. Let's talk about the attic hatch specifically for a moment, because it deserves more attention than it usually gets. In a lot of homes, built before energy codes started requiring insulated, weather-stripped attic access, so the hatch is nothing more than a thin sheet of plywood or drywall sitting loosely in an opening. No insulation value to speak of, no seal around the edges. On a cold night, standing directly under an uninsulated hatch, you can often feel the temperature difference with your bare hand held a few inches below it. That's not your imagination. That's measurable radiant and convective loss happening right above your head, every single night, 12 months a year in most climates, worse in winter. I want to give you a mental model that sticks, because building science concepts are easier to remember when they map to something familiar. Think of your attic like the underside of a garage door. If the garage door panel itself is well insulated, but the weather stripping around the edges is torn and gapped, cold air pours in around the perimeter no matter how good the panel insulation is. Nobody would look at that garage door and say, "We just need a thicker door panel." They'd say, "Fix the seal first." Your attic hatch is the exact same problem, just facing up instead of out, and somehow that obvious logic gets lost the moment the conversation shifts to attic insulation instead of garage doors. Here's another angle worth understanding: the stack effect. Warm air rises through your house and wants to escape at the highest point it can find. That's basic physics, nothing exotic about it. As it escapes through your attic's leak points, it creates a slight negative pressure down at the bottom of the house, which then pulls cold outside air in through gaps around your foundation, your basement windows, your exterior doors. This is why sealing the attic doesn't just help the attic. Homeowners who properly air seal their top plates and hatch often notice fewer drafts at the front door and around baseboards on the ground floor too, because they've slowed the engine that was pulling that cold air in from below in the first place. The house is one connected system. The attic just happens to be where the exhaust valve for that system usually sits, wide open unless somebody bothers to close it. Before they ban this kind of DIY air sealing under the next round of certified contractor-only rebate rules, and some jurisdictions are already tightening who's allowed to self-certify for energy credits, you need to understand what you're actually looking at up there, because once it's gate-kept behind a licensed inspection requirement, the $40 fix quietly turns into a $400 service call. Let's geo deeper on why the industry structured itself this way, because once you see the mechanics, you can't unsee them on every future estimate you get. Insulation contractors, especially the bigger regional and national franchise operations, are generally paid and evaluated on volume. Bags installed, trucks dispatched, square footage covered per crew per day. Air sealing work is slow, detail-oriented crawling work. It doesn't scale the same way. A crew can blow 10 inches of loose fill across an entire attic in under 2 hours. That same crew doing careful air sealing, foam here, caulk there, checking every top plate, testing every can light, might spend 3 or 4 hours doing work that generates a fraction of the material revenue. From a business standpoint, air sealing is a money loser relative to a straight material and labor insulation job. So guess which one gets pushed on the sales call, and which one gets buried in the fine print as included, weather permitting. This is also why so many of these companies will happily quote you an insulation R value upgrade, but get noticeably vague the moment you ask specifically, will you be air sealing the top plates and hatch as part of this job, and can you itemize that separately on the invoice? Watch how many of them suddenly need to check with the crew lead, or get back to you on that specific question. That hesitation is the tell. A contractor who's actually doing the work right will answer that question in about 4 seconds, because it's the first thing on their checklist, not an afterthought. There's a second layer to this too, and it's uglier. Some regional rebate and financing programs are structured so the contractor gets paid a percentage of total job cost, not a flat referral fee. That means the contractor's own compensation goes up when your job costs more. Read that again. The person quoting you the price has a direct financial incentive for that price to be as large as possible, dressed up as comprehensive service. It's not universal. Plenty of programs are. 43630. The solution structured fairly, but it's common enough that you should ask directly how your contractor is compensated on any rebate-linked job before you sign. None of this means every insulation job needs to be a DIY weekend project. Bigger attics, complicated roof geometry, knob and tube wiring, vermiculite that might contain asbestos, or a genuinely undersized existing insulation layer are all legitimate reasons to bring in a professional crew. The point isn't never hire anyone. The point is, know what the $40 fix looks like so you can tell the difference between a contractor doing it right and a contractor padding an invoice with material you don't actually need yet.